Hello everyone, and welcome back. I wanted to make a short video because I realized I forgot a pretty important but simple definition. And that definition is for mechanical energy. It's a term you will see in any first year physics course and on the AP exam. So I'm just going to jump right into it. Mechanical energy is the combination of kinetic energy and all potential energies in your system. So let me bring up my bar chart. So what this means is mechanical energy includes all of these and all of these, but not work because work is a transfer. And the big one is it does not include internal energy. Now, the big thing here is you're only really dealing with internal energy in a first year physics course if force friction is coming into play. Now, we did a roller coaster problem earlier, and this situation has no friction. Here I have the very beginning of the roller coaster. The coaster is at rest. I'm just going to put things in terms of energy. We have 100 joules of gravitational potential energy, 0 joules of kinetic energy, which means my mechanical energy is 100 joules. A fly lands on the roller coaster, and the roller coaster begins to go down the hill. Basically, all it's saying is the roller coaster starts to move, and yet, yes, that is an example that was directly from an AP exam. Now, at the bottom here, height is 0, so there are 0 joules of gravitational potential energy. How much kinetic do I have? Well, if it's frictionless, I have 100 joules of kinetic energy. That means I have 100 joules of mechanical energy, because mechanical energy is all potentials and kinetic. At the top of the loop, I have 60 joules of potential energy. That means I have 40 joules of kinetic energy and 100 joules of mechanical energy. At the final plane here, I have 20 joules of gravitational potential energy. Therefore, I have 80 joules of kinetic energy and 100 joules of mechanical energy. So the real big takeaway comes down to this. Mechanical energy is not conserved in the presence of friction. If it is a frictionless situation and you know there is no work being done, then all of your mechanical energies need to be accounted for. In other words, everything in this circle and everything in this circle needs to add up to the same value. The frictionless roller coaster is a very simple example of this that is used pretty often, because then if they really want to test if you know this concept, they'll add something like a small friction mat just to see if you recognize that mechanical energy is not conserved in that situation. This idea may come up here in this topic and also tends to come up in simple harmonic motion and pendulums, which comes up later in the year. So like I said, I wanted to make this short. I'm going to keep it at that. Other than that, have a good day. This is Mr. M signing off.